Now I would like to show you the solution for continuous beams, pre-stressed continuous beams, and I will start with this few pictures of this presentation, so that you just have an idea of the types of the structures which we can solve. This is a post-tension bridge in this cross section, which can be done. You can also try or to model such type of structure. This is hollow core, or here we have various types of the beams, including these composite beams. Recently we added the possibility to have such continuous composite beams. For this type of structures, we decided to generate an effective model and not to bother the user with our logic how the model is built. So we do not concentrate on, or do not focus on a general solution, but we want better to do a special program for the types of bridges which is most frequent in the practice. I would say, let's say 80%, because those big bridges with cantilever construction, cable stayed, or suspension bridges, we do not want to address, or we do not want to solve, but this one, this program should be effective for the types which I showed before. So let me to start a new project, and we have a small wizard in which we can input basic data, and the program will generate the model for us. You can see that we have cast in situ beam or prefabricated. This prefabricated can be reinforced, pre-tension, post-tension, and last one is composite, pre and post-tension, which I want to select. I want to have continuous beam, and this is beam alignment and support positions. Then I have to select if I want to use beam in 2D or beam in 3D. We have one type for this selected continuous beam with composite slab. We have the only one type of construction sequence yet, and we have to define the cantilever, the spans, and right cantilever, and we can continue in the wizard. Again, we can use this bridge code, select design code. We can generate or not generate groups for bridges, and we can define the cross section. Now the cross section is composite, so I have to select either these predefined sections, or in advanced tab sheet I can open this general editor, and we probably have to make it smaller so that you can see it. Sorry about it. Now we see that we can import it from DXF file or from table, but also we can add a cross-sectional component, and in this cross-sectional component I can select this T-shape with hinged wall. I can change the parameters. This is 1000. 1000 is width, 280, and here we have 70 and 50. That's it. You see that this part is used in fact as a kind of force fork for the slab, and also the joint is quite wide. We have C50, 60. I can say OK, and I can add a new component which will be rectangular cross section, again 1000 millimeters. Sorry, the depth is only 200 millimeters and the width is 1000 millimeters, and my composite slab will be C37. Now I say OK, and if I select the first part, and I see here that we have a point 2, so our insert point must be selected as 2, and our point in the other part of the section, other component is 8, and now we have the cross-section as I want. We can check if the face is defined, if our material is correctly defined. If I say OK, then I have it back here. My diaphragm above the support will be rectangle, and the width I select the same one, 1000 millimeters. I want the program to generate cell weight, and my permanent load will be -3, because it is in fact the part that I showed before the break. I showed the import of this moving loads. Then we are analyzing only one beam of I would say the model, the 3D model could be a slab with ribs, or it could be orthotropic slab, or it could be grillage analogy. So definitely we can do it like this. I want the program, because I will not be importing the moving loads, I want to have some substitute load, and I want the program to generate critical load patterns. Then there are my beams. The spans already were input, so we see that this is not editable, but we can edit the these cantilevers, or I would say these parts which are behind and or before and after, or here of these beams. This is again possible to edit. I'm happy with the input, and my age, equivalent age of prefabricated beam at the moment when the slab is cast is 60, 70 and 80 days, for example. It could be the same age, but if I really want to analyze the effect of this different age, I can make it different. This 80 is taken from this part, from this input data, but we can add some additional serviceability stages. Then I go to next, and I have my input for individual beam, beam 1, beam 2 and beam 3. I can use identical history of prefabricated elements. This should be okay. Also I have this cantilever on storage yard. I'm happy with that because I prepared the example in advance and the program remembers the data. Here temporary supports also 0.5 is okay for me. Also this data is okay. I will mention about this transfer of pre-stressing later. For beam 2, as it is longer, then the program identified this different data, so I will repeat 1.5. This is okay. My transport was not adapted, so I can switch. I did not do it before, so I would have to do it here, and then it is adapted also here. But if I switch it off, then this construction stage will not be done, and you see that this is disregarded, it is shaded. This input is also okay, and I just check this one, it looks okay. I finish and I get the data generated by the program. Now I have it here. I can change all these parameters if I want. Here we have a model. Here we have cross sections. For example, sometimes we need to have a higher section above the support, so I make it 1400 instead of 1200, and now you see that we have such arrangement below, above the internal support. These are my nodes and supports. I can edit, I can do whatever I want. In case that I have different example, now it is not reasonable to make haunches, but I would be able to make haunches, and here we have load cases. There are quite a lot of load cases because the construction stages are more, I would say, complicated, and also the program generated these critical load patterns, okay, as the additional, or I would say substitute load, which I wanted to have. At the moment, I do not use this bridge code groups, so I have it defined as it is now. If I switch into bridge code, then I would delete this variable loads, and we would have to generate it once again, or we would have to import it from some other software. Again, we can add point loads, point moments, uniform loads, line loads, settlements, user-defined forces, and we can check the combinations. The combinations are, again, as I explained, for individual construction stages. Now you see that we have plenty of construction stages, and in each construction stage we have a lot of load cases defined because they has to be defined due to the changes in construction stages. To be oriented better in this, we can go to construction stages, and instead of model I will switch on load history, and then you see all these increments of loads which are step by step added to the structure. It is of course schematic picture, so you can also see rheological effects, which are the load cases R. R8 means that it is in construction, added in construction stage 8. Okay, we have three types of pre-stressing in stage 2, in stage 5, and in stage 8. That is due to the fact that our age of the beams is different. But let me to go to settings first. You see here we can change the number of intervals, calculation of nonlinear creep. But we have new dialog for member history, and this member history is related to the history of this precast elements. If we select member 3, this is the one, then we see the history of the member, and I want to adapt something. I mentioned that transfer of pre-stressing is here I would need to have a wider. Oh, we cannot move. It doesn't matter. I will do it somehow. Now I can do it now. So if I want to change this 5 days, I say I want to use user-specified strength of the concrete, and then I say, for example, my FCK at the time of pre-stressing will be 30 megapascals, and then automatically we have this age adapted to 2.9. If I say 20 megapascals, I have it 1.3 here. Okay, means that the user decides what is the strength of the concrete at the time of pre-stressing, and the concrete and the program calculates equivalent age. It is written in Eurocode that you cannot apply age below 3 days. But if you do it like this, and this is also what Eurocode says, if you take some measures that you guarantee the strength 30 megapascals, then you can do it, and the program will not limit the check above 3 days age. So now we will perform, if it's 2.9, we will perform the code check. Then storage yard probably would be 3 days. This is first adaptation, and the second what I want to do is in this casting of composite slab. Casting of composite slab, you can see we want to have In this case, we have here in this picture, in the top, internal support. This was defined in Wizard, I didn't mention. But we can define that we want to have a required camber. We can define it by value, like 0, which means that we only balance existing deflection, or we can define -20, +20 millimeters, depends on the structure. But the beam is very short, so I say I do not want required camber, which means that now the support will be there, but will be applied to deformed structure. Okay, will be applied to deformed structure. If it's not, if you want to push it up, then probably there would be a too big negative bending moment. So that's the adaptation which we have to do in all three members. So transfer of pre-stressing UC5, and we can adapt it here, user specified strength 30 megapascals, and probably here I want to have 3, and in casting of composite slab I will change this required camber, and for the last one, this one will be transfer of pre-stressing, user specified concrete strength 30 megapascals, and here we have to put 3 days, casting of composite, required camber will not be there. Hey, just let me to check, this is okay, this should be okay. So I have it okay. Now this is, those are the sections above the support, these diaphragms. So they have only one small history, and that's the casting. As the program writes here that the global time axis is not valid, we changed the parameters of the axis. We have to press here the button, this regeneration. Now we have regenerated this data, and we can go to construction stages, and we have it defined as we want it. If you have no question, I just check if I specified all necessary data. I hope so. Then we can save the data as GR, for example, not PT slab, but composite continuous. Now we have it, and I can go to tendon design, and you will see how I can define the tendons. First, we define 3 tangent elements. That must be defined to each member separately. So but first I should go to design members. Design members. You see our beam, and here we have stressing bed defined. Stressing bed, you can adapt the data whatever you want. I have to remind this duration of short-term relaxation. We have some default value, but if you really calculate it according to Eurocode, then the value is usually much higher in the case that you speed up the hardening of the concrete by heating. Okay, we see this is the loss due to difference in temperature, and we define here 50 centigrades. So then we should also adapt this one, which we can do in Excel spreadsheet, which I can send you if you like. Then I cancel it and I go to tendons, and you see that when I select here free tangent load case in the stage 2, the program automatically identified the oldest prefabricated element, member 9, and I can define the tendons Unfortunately, all these icons are packed because of this small resolution. So I can import new tendon, and I prepared it in advance in text file. My text file is here, so I open it, and you can see that I got immediately the tendons here. I can show, instead of uncoiled view, I can show design view, cross section, and if I go to, let's say, 35 meters, I have it. This is G1, G2. Unfortunately, the program imports only the geometry, not the material. So, sorry, I have to select different strand, 1860, 12.5. This is the one which I had. 12.5. This is what I prepared. Also, my initial stress can be higher. Here we have calculated the maximum one, but be careful if you have if you specify the maximum one and then your losses are a little bit lower than we expect. It depends on the input. Then of course program would check and it would not be satisfactory. So you can make it by trial and error method. I use 1450 megapascals, and then if I make it too high, then the program would definitely calculate it and would make it smaller, or would show you that there is a problem. So this is the adaptation. We can also see what was the input. If you want to input it manually, then you would select this edge and define the distances from the edge. The example which I showed has no debonding, so I can show design view uncoiled, and I have it defined, at least these pre-tangent beams. I can show the other one, and I can again import it from text file. You see it is done, and already the program identified the same strand and the same initial stress, so I can continue with additional import from text file. Okay, so we have 3 groups I think we have 6 groups, so 2 in each prefabricated element. Additional possibility of how to define post-tangent tendon is you can either select post-tensioning here, and then you see that you have all design member, which you can check or you can define, and your tendon can be either defined using segments, take supports into account or do not take supports into account, polygon, or import from text file, from table, Excel table, template, or the DXF. Template means it is similar as I described user templates for reinforcement of the cross sections. If you define your own geometry of post-tensioning tendon and then you applied it to the same type of the bridge, like 3-span or 4-span continuous beam, then the program will adapt the dimensions and will use your template, and you can share the template with your colleague, and there is no problem with it. I do now the import using segment because it's good enough for me. I want to take supports into account, and I have the tendon here. I can adapt the tendon if I want. For example, I do not like here the eccentricity, the tendon should be lower, because this part above the support is not pre-stressed at the bottom, and I would have the troubles to get the tendons and especially the strands here in this part where we have anchorage length in compression. So that's why it is good to select these and say, for example, here we would have minus 300 millimeters and it goes below. So here also minus 300 millimeters, and we can adapt it. Of course, I could change, for example, this straight part using these parameters here, or tune the tendon shape in other way, but I don't think it is necessary at the moment. The only what I have to do is that I change this type of strand to did I change it? 12.2, 12.5, sorry, and I think it was 5 strands which I had there, which is diameter of tendon about 60 millimeters, and last what I have to check is the detail, if I have number of strands, my friction coefficient, stressing from probably both ends. No correction, I would correct the relaxation. We can always gain about 10 megapascals of the loss, some anchorage set, and here we can increase the stress of this post-tension tendon. We have maximum is 476, I will use 475, let's say 475, and that's it. Okay. This is what I like now. Maybe I can show you. This is quite nice feature. Unfortunately, you cannot. Here we can see 3D. So you can see your tendons, you can check it. Or I go to cross section and I can start from 0 and I go and my tendon goes up and down, and this can check it in each section. Or design view uncoiled, and here you see that we have in uncoiled view we can have scale. This is a real slenderness. We can make scaled pictures, scaled view. We can also show XY plane if we want. Now I do not want to show it. We can draw, for example, tendon shape here, and in this tendon shape I can, for example, show tendon spacers. So you see that we defined the grid in the program in which the program should identify. For example, my spacers would be 200, 400, 600, 800 millimeters and so on. And the program calculated, for example, for 1000, we have to put this spacer to 13.72 meters from the end of the beam, so that we fix the position of the tendon. Of course, you can say go to DXF and you export this as a preliminary draft drawing of the program. Okay, this is quite complicated shape, but if I can also show tendon shape labels, which now you see there are plenty of curved parts, straight parts. So you can either use it or move it in your AutoCAD drawing or whatever you want. So I do not draw it. Now it looks I can show short-term losses. Here we have short-term losses. Some of the checks are done, some of are not done yet because we have not calculated. These are done. And here we have not calculated the losses. I mean long-term losses. Here we have short-term losses and so on. I exit. Now I have it calculated. I save the data and I have it defined, defined the tendon. And I can calculate the solution. Now, of course, the calculation will be a little bit longer because you mentioned that there were plenty of construction stages. In each construction stage and also in the detail sub-intervals, we have to calculate the structure to perform finite element analysis. So that, sorry, I can hear you. No question? Okay.
Now I got one question.
Yes.
You can hear me?
Yes, please. Yeah.
The losses of the friction, there's only one value, or there's an upper limit and a lower limit?
There is one value for curve and one value for straight path, and we do not have upper and lower limit, unfortunately. I think that's the reason why we have R sub and R inf in Eurocode, that coefficients, because in fact you apply this for serviceability limit states. I do not know anything about this. I know that it is it was used in old code in Netherlands, and I experienced this, but we have not introduced it, as it was not in Eurocode.
No, so you have to make two models, just one model, and then change it once, and then you can have them both.
Okay, so this is the envelope of internal forces. We can also check some other forces. For example, for stage 2, you see one beam. Stage 3, we have different, and we can, for example, stage 8. Yes, so you can check all these, also deformations and reactions. Of course, also individual stages. For example, post-tangent tendon is like this. Okay. Then we go to concrete design, and we can check or disregard some of the checks. We can use redistribution in case of non-pre-stressed. This is pre-stressed structure. Also reduction of moment, limited interaction check, all these things is possible, are possible. And now we have this definition of reinforcement zones. Program identified the zones as we know that it is prefabricated element, then we have different zone AA and different zone BB. So probably we do not want to change anything. I do not recommend to use this possibility to check, to perform code check here, because it is quite fast for non-pre-stressed concrete. You do not need to define specific sections in which you want to check it. But for pre-stressed concrete, it is much more reasonable to use this table in the bottom. So I do it, and we see that the program calculated or proposed to have different sections above the support and at midspan. Here we have red one. Here we have red one, for example. I will adapt a little bit these positions. So this one, I would say I would do 1 meter from the distance. Then I have it here. You see. Then this one probably I can. This is okay. Section 3. I do not want to have it exactly above the support. So maybe I can switch into here, let's say 1.5 meters. Okay, and then this one, it should be okay. This one, I think let's keep this. It is the section 5, which is 0.5 from the 0.7, but I can delete the other one. This one I can delete, and this one I can also delete. Okay, now I have a certain amount of sections. I can go to detailed analysis, and now, as you saw it before, the program generates the data for this standalone reinforced concrete program. Actually, after it is generated, you cannot change the data in this program, but you can save it as, and if you save it as, you can change anything. So now we have it. I have to make it smaller. So now you see we have all the sections, value, all this, we have plenty of extremes in each section. We can see what types of section we have here in this info window. We can press all and we can calculate. Now we see here that we have a progress bar, and the program calculates in a multi-threaded calculation the data. You can, here we should probably make it now it is calculated. I will make it smaller so that I see the results, and here are the limits. Here we see what is wrong, and we see that wrong is in section 7.30 meters brittle failure, which has to be checked according to Eurocode for bridges. Of course it is a problem because we have no non-prestressed reinforcement, so any tension here must be transferred by the reinforcement. So I go, if we don't have Eurocode for bridges, then this check will disappear. We will not check it because it's not required strictly according to the other Eurocode. So we should now make or define some reinforcement. So let's start with this first section, which was here. This is this section BB, and I will use this manager of user-defined reinforcement. I defined in the past such reinforcement of the same shape, same type of section, but different dimensions. If I say apply, then the program will position the reinforcement into the cross-section, and you can see that it fits the cross-section, everything is okay. And as it was BB section, so any additional section which we have of the same is already reinforced. Okay, so we have only the first one, sorry, the last one, which is this rectangle, was not reinforced. And then we can use standard template, predefined template provided by IDEA. We can have 4 bars, number of lower bars I would make also 4, now diameter 16, stirrups, double system of stirrups. We can try this one, so it looks like it is okay, and we can try the calculation again. What happens now after we reinforce it? See, this is already here, already finished, so we can select it and take some capacity. Here we have this kind of response, and my lever arm is very small. So so in such case, you can always go to reinforcement and change this set for shear and use user-defined value of lever arm. Check on here. which is always possible, and then we disregard the flexure, which in fact, in my opinion, the check of shear should not be directly related to lever arm from flexure, because we have different distance of top and bottom part, or top and bottom stringer defined by reinforcement anyway. So sometimes when we calculate the lever arm from response, then it is necessary. It is written in Eurocode. It is Eurocode, but I believe it is not. I would say in general cases it is not correct, and we should know how to avoid it. In this case, I have to say that I could change it here in shape, set for shear, use a defined depth, and say, for example, this would be the 1000 millimeters, and here would be 900 millimeters. And then if I go to shear, then this calculation is okay. Okay, so it should be a correct solution. Sorry about that. I was ill recently and I'm still not completely okay. So now I can recalculate all, and we have it. So I will switch off now the recording.